Okay, good day to all of you. So in this video tutorial, we're going to learn how to do unsigned binary division. So the term unsigned means that we're only dealing with positive binary integers. We are not concerned with negative numbers, but only positive numbers. But before we continue with our illustration and demonstration of how to do binary division, let's review the single bit binary subtraction with borrow, because this is very important, because just like in our number system, the decimal number system, if we're dividing a number, we are also part of the division process is subtraction. So that's why we have to review the binary subtraction here, because in binary division it's also used. So given two binary digits x and y and a borrow in z, so we get the following difference and borrow. So for the first condition is the borrow in is 0. So the values here of z are all 0. So the first condition is we have 0 minus 0 is, there is of course 0, no difference. It's not no difference. The value of difference is 0 and borrow in is also 0. Next condition is 0 minus 1 is we have 1 borrow 1. So why does borrow in has occurred? Because as you can see here, we have this the minuend and then we have our subtrahend. Which of this is the larger value? Of course, it's the subtrahend. So since this has the larger value and has a negative number, you will need to borrow value from the next digit. So that's why we have 1 borrow 1. Okay, next is we have 1 minus 0 is 1 and then there is no borrow in. So actually, as we can observe, we have only one once, then why is it the other has a borrow in while the other is not? Again, it depends upon the position of 1, since 1, which is in the minuend, it is larger than the subtrahend, which is 0. So that's why it will not incur a borrow in. And then last but not the least is we have 1 minus 1 is we have 0 and then there is also no borrow in. Okay, that is for borrow in, which is the values are 0. What if the borrow in has values of 1? So for this one. So for the first case is we have 1 minus 0 is 1 and then 1 minus 0 is 1. And then why do we have a borrow in? Okay, just bring down 1 and there is a borrow in because the 1 is actually in the borrow in. So you need to reflect it in the borrow in. Okay. And then next is we have 1 minus 0 is 1 and then 1 minus 1 is 0. And then again, why does it have a borrow in? Because we have to look at the minuend and subtrahend. The minuend value is 0 and then the subtrahend's value is 1. Meaning, subtrahend has a larger value than minuend. So you need to have again a borrow in. So that's why there is a borrow in here. And then next condition is we have 1 minus 1. We have 0, 0 minus 0, 0. We have no borrow in. You may wonder again, you have two ones here and then two ones here. But why is there a borrow in here and in the third condition does not have? Because again, as you have observed, 1 here is in the minuend and then subtrahend is 0. Since minuend is larger than the subtrahend, so it will not incur any borrow in. And then last but not the least is we have, okay, to evaluate this, let's evaluate this first two. So 1 minus 1 is 0. So actually this one, 0 minus 1 is just the same with this one. So 0 minus 1 is 1 borrow 1. Just the same. So you have to remember the principle of binary subtraction with borrow because it's very important if we're doing division. So let's have the first example for our unsigned binary division. Okay, so for our first example is we have 1, 1, 1, 0, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, for example, then this is our value 1110, 1110, 001. and then divided by, okay, so we have 1, 0, 1, 1. So what are we going to do first? First is you have to know if for this one, so 1 divided by 1, 0, 1, 0, 1, 1, so it's not enough. Does 1, 1 is big enough for 1, 0, 1, 1? No. 1, 1, 1, is it big enough for 1, 0, 1, 1? No. So 1, 1, 1, 0, is it big enough for 1, 0, 1? Yes. If it's big enough, let's put 1. So we have 1 times 1, and then 1 times 1 again, and then 1 times 0, and then 1 times 1. So we multiply just like our division in our decimal number system. And then we're going to subtract. So that's the tricky part. So we have 0 minus 1. So subtrahend is larger. So we have 1, borrow 1. So 1 minus 1 is we have 0. 0 minus 1 is again 1, borrow 1. And then 1 minus 1 is we have 0. Okay? And then will there be a borrow in? No, because the 1 is already in a minuend, not in the subtrahend. So this will also be 0. So you can just omit this one. So next is we have bring down 1. Okay. Is this enough for 1, 0, 1, 1? Of course, it's too small. So we're going to put here a 0. So let's just put 0 here. And then next is 1, 1, 1, 1. Is it enough for 1, 0, 1, 1? Of course. So it's a 1. So as you can see, if we multiply it, we are going to multiply 1 with 1, 0, 0, 1. It's just the same with the value. So we have 1, 1, 0, 1. And then we're going to subtract. So we have 1 minus 1 is 0. 1 minus 1 is 0. Bring down 1. And of course, this is 0. So we have 1, 0, 0. Then next is bring down 1. So is it enough for 1, 0, 1, 1? Actually, no. So it's a 0. So we're going to put 0 again here. So we have 1, 0, 0, 1. And then next is we have, okay, we have to bring down 0. So, is it enough? Of course, it's already 5 digits, so it's 1. So, we have 1, 1, 0, 1, and then subtract. So, we have 0 minus 1 is 1, borrow 1. 1 minus 1 is 0. 0 minus 1 is 1, borrow 1. And then bring down 1. Since our 1 is in borrow in, we need to borrow here again. So we have to have a borrow in. So 1 minus 0 is 1. And then 1 minus 1 is 0. Do we need to have a borrow? Of course, because the 1 here is in the subtrahend and larger than the minuend. So 1 minus 1 is we have 0. So we can remove that. And then next is we have bring down 0. So we have 1, 1, 1, 0. Is it large enough for 1, 0, 1, 1? Yes. So let's copy again the value 1, 1, 0, 1. So subtract. So we have 0 minus 1 is 1, borrow 1. 1 minus 1 is 0. 0 minus 1 is 1, borrow 1. 1 minus 1 is 0. And there's no borrow because the 1 is in minuend, not in subtrahend. Minuend is larger than the subtrahend. And then 1 minus 1 is 0. Actually, just the same with our first value. Okay, next is we have bring down. Okay, we have to bring down 1. So, is this larger than 1, 0, 1, 1? So, it's not. So, we have 0. And then, let's just put 0. So, minus 0, 0. So, it will just have 1, 1, 1. So, this is our answer because this is already smaller than 1, 0, 1, 1. Remainder we have 0, 1, 1, 1. Okay, so let's compute. So what's the value? So 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. So let's add 512 plus 256 plus 128. And then next is we have 32 plus 16 plus 8 and then plus 1. Okay, so let's add. So 2 plus 6 is 8 plus 8 is 16 plus 8, 18. 18 plus 6 is 24 plus 8, 32 plus 1 is we have 33. 3 carry 3. 3 plus 1 is 4 plus 5, 9 plus 2, 11 plus 3, 14 plus 1 is we have 15. And then we have 1 plus 5 is 6 plus 2, 8 plus 1 is 9. So we have 953. So 953. So we have this one. What is this? So 1, 2, 4, 8. So 8 plus 2 plus 1 is we have 11. Okay. So we have 95, 953 divided by 11. So we have 95 divided by 11. So we have 8. Okay, so we have 88. So we have 15 minus 8 is we have 7. And then, of course, 8 will become 8. So 8 minus 8 is we have 0. And then 73. So 73, so we have 6. So 6 times 11 is we have 60. Okay, 66. So minus, so we have 13 minus 6 is we have 7. And this will become 6 minus 6, 0. So we have 86 remainder 7. So let's compute if this is 86 remainder 7. So we have 1, 2, 4, 8, 16, 32, and then 64. So we have 64 plus 16, and then 4, and then 2. Okay, so we have 4 plus 6 is 10 plus 4, 14 plus 2 is we have, okay, we have 16. Okay, and then 6 carry 1, 1 plus 6, 7. Okay, we have 8. And then our remainder is 1, 2, 4, 8. So we have 4 plus 2 plus 1 is we have 7. So our answer is this one. So 86, this is 86, remainder 7. So that is how division is done in unsigned binary division. So to further understand and reinforce our learning, so I'll provide another example. Okay, so we have 1, 0, 0, 1, 1, 1, 0. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Divided by 1, 1, 1, 0. Base 2. So, okay. So let's check. Is 1 enough for 1, 1, 1, 0? No. 1, 0. Not also. It's 2 digit. For 3 digit, no. For 4 digit, is it already enough? No. The divisor is still larger than the portion here at the fourth with 4 digits. So let's try, of course, for 1, 0, 0, 1, 1. So it's already larger. So it definitely fits 1, 1, 1, 0. So it's a 1. So let's copy the divisor. So 0, 1, 1, 1, and then minus. So 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 1 is we have 1, borrow 1. So 1 minus 0 is 1. 1 minus 1 is 0. Okay, do we have a borrow in? We have. Why? Because again, the 1 is in the subtrahend and not in the minuend. So this makes it larger. So we need to borrow and this will be 0. So let's omit this one for clarity. So next is we have bring down 1. So is 1, 0, 1, 1. Is 1, 1, 1, 1, 1, 0 fits here? So no, it's a 0. So actually, you can bring down the next digit, but for clarity, I'm just putting zeros here. So we have 1, 0, 1, 1, and then bring down the other one. Since it's already a 5-digit, it really fits 1, 1, 1, 0. So again, copy 0, 1, 1, 1. So let's perform subtraction. So we have 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 1 is 0. 0 minus 1 is 1. Borrow 1. And then 1 minus 1 is, of course, 0. Okay. So, next is bring down 0. So, does 1, 1, 1, 1, 1, 1, 1, 0 fits? Of course, it's already a 5-digit. It's also a 1. So, let's copy again. So, 0, 1, 1, 1. And then subtraction. So we have 0 minus 0 is 0. 1 minus 1 is 0. 0 minus 1 is 1. Borrow 1. 1 minus 0 is 1. 1 minus 1 is 0. So do we have a borrow in? Yes, again, because our 1 here is larger, which is subtrahend larger than the minuend, which is 0. So again, it's also a 0. So let's omit it again and then bring down 1. Does it fit for 1, 1, 1, 0? No. So it's a 0. So let's just subtract 0. So there's no, actually you can omit this portion. Just bring down the next digit. But for clarity, so that you see the whole process. So we have 1, 0, 0, 1. And then bring down 0. So 1, 0, 0, 1, 0. Does it fit? Of course, it's already a 5-digit. So it's a 1. And then let's copy. So 0, 1, 1, 1. Okay, then subtract. So we have 0 minus 0 is 0. 1 minus 1 is 0. 0 minus 1 is 1. Borrow 1. 1 minus 0 is 1. 1 minus 1 is we have 0. Do we have a borrow in? Yes, again, because subtrahend's value is larger than the minuend. 1 and then minuend is 0. So 1 minus 1 is 0. So we have. Okay, so we already finished with the digits, and also it's already small. Already a small value, and then there's no digit anymore. So this is the remainder. So there is a possibility that if we're going to have a division, there is always a remainder. It's not always exact. So you just have to indicate your remainder. So remainder 0, 1, 0, 0 base 2 for clarity. So we have this one. So let's check if our answer is correct. So we have 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. So let's add the numbers of 512. And then we have 64. And then we have 32. And then 16. And then we have 8. And then we have 2. Then let's add. So 5, 12, 64, 32, 16, 8, and 2. Okay, so 2 plus 4 is 6. Plus 2 is 8. Plus 6 is 14. 14 plus 8 is 22. Plus 2 is we have 24. 4 carry 2. Then 2 plus 1 is 3. Plus 6 is 9. Plus 3 is we have 12. Plus 1 is 13. 3 carry 1. Okay, next is we have 1 plus 5 is equal to 6. So we have 634 for our dividend. And then next, what is the value of our divisor? So we have 1, 2, 4, and 8. So 8 plus 4 plus 2 is we have 14. So we have 634 divided by 14. So how many 14s are there in 63? So 14 times 5 is 70. So let's try 14 times 4. So 4 times 4 is 16. 6 carry 1. 4 times 1 is 4 plus 1 is we have 5. So we have 56. So we have 4 times 14 is we have 56. So we have 13 minus 6 is we have 7, and then this one is we have 5. It will become 5 minus 5 is we have 0, and then 74. So we have 74 divided by 14 is we have 5. So 5 times 14 is we have 70. So our remainder is 4. So we have 45 remainder 4. So let's check if the answer is 45 and then remainder 4. So we have 1, 2, 4, 8, 16, 32. So we have 32 plus 8 plus 4 plus 1. So we have 32 plus 8. 2 plus 8 is 10 plus 4. 14 plus 1 is 5. 5 carry 1. And then 1 plus 3 is 4. 45. And then the remainder is 1, 2, 4, 8. So we have here the remainder 4. So our answer is correct. So this is our unsigned binary division. So just like our division in our decimal number system, we're of course doing the division and then multiplication, and there is also the subtraction that a little bit tricky. So you need to be very aware of the how to subtract with borrow. So I hope that you've learned and you are cleared already with unsigned binary division. So if you have any comments, suggestions, and questions, so please feel free to comment down below. And then don't forget to like this video and subscribe to my YouTube channel. So thank you very much. Good day and stay safe.